So today I wanted to talk to you about the product rule for doing derivatives. So if you've never heard of the product rule, that's okay. Or maybe you have heard of it, and that's okay. But I'm going to show you a couple of quick examples, 3 examples in just a minute. But first, if we're just meeting, my name is Mark Nolde. I have been teaching high school math and college math for over 20 years, and that includes my 4 daughters. So stay tuned, and we're going to make you good at math. So here's one quick example of the product rule. So the instructions might say something like, use the product rule to find the derivative of the function. So do you have to use the product rule? Well, no, only because they're saying product rule. But this is a product. In the beginning, we would have learned just to FOIL these two things out. First times first, outers, inners, last times last, and then we would differentiate it term by term. But since we just learned the product rule, we're going to use our product rule formula, which says if you have a product called h of x, that is f of x times g of x, it says that if you take the derivative of h, it's going to be equal to the derivative of the first function times the derivative of the second function plus the derivative of the second function times the first function. Now that might appear, differently in books, different textbooks and so on. This is just the way I learned it when I was in high school. But I'm multiplying here and I'm multiplying here. Multiplication is commutative. And then I'm adding here. So addition is commutative too. So just keep that in mind when you look at, say, different textbooks, or maybe your teacher or professor has taught it a little bit differently. So that's what I'll use. So let's see. If I wanted to take the derivative of g, I would first have to take the derivative of this, derivative of the first function, which is 2, multiplied by the second function, 1 minus 5x, plus the derivative of the second function, which is negative 5, times the first function, 2x minus 3. So I'll write that in here. I think I'll write that in here, 2x minus 3. So if this were like a competency in one of my courses, at this point here, you'd be done. But you might want to learn how to clean these up, because in the end, you may have to set them equal to 0 so that you can get critical values. So we'll start by distributing this 2. Gives me 2x minus 10x. Then I will distribute this negative 5, which would give me minus 10x. Let's see, minus times minus, that's a plus. So plus 15. Then I can go through here and I can add my like terms. So I have 2x terms, I have 2 constant terms. So that would be, let's see, negative 20x plus 17. So a lot of times when you first see this, you're like, really, does that work? I'm not sure that works. So what I like to do is say to students, take this, multiply it out. So just take your g of x and multiply that out. So when I multiply that out, first times first is 2x. Outers. Right, when I look at my outers, 2x times negative 5x, that gives me a negative 10x squared. Then I'm going to look at my inners. Negative 3 times 1, negative 3. And then, let's see, last times last. Negative 3 times negative 5x. That gives me positive 15x. So if I go ahead and simplify this a little bit, this is my g of x multiplied out equals negative 10x squared plus 17x. That's adding this 2x and this 15x and minus 3. So now I'm going to go ahead and take the derivative term by term after I have multiplied it out. So let's see. 2 times minus 10, well, that's a minus 20. X to the 1 because I reduced the power by 1. And let's see, 17x. That becomes a 17. And this guy over here, he just goes to 0. So that goes to 0. So I have negative 20x plus 17. When I go back over here, hey, look at this. When I did the power rule, when I did the product rule, I got the same thing, negative 20x plus 17. And that's a very basic one. Show you how it goes. Show you another one in just a second. Stay tuned. So here's my next example. Notice here too that we have a product. I always like to put a multiplication sign in between my products. Now, could I multiply this out, right? Distribute x cubed on each term over here. Distribute 4x on each term over here. Add them all up and then differentiate term by term. Yeah, I for sure could do that. But here's what I'm going to do. I'm going to use the product rule, which says, let me undo that. Go back to the other color. F prime of x is the derivative of the first. So this is the first derivative of f of x. So that would give me 3x squared plus 4. 3x squared plus 4. Times the second, so it's this whole term, this whole thing here. 3x squared plus 2x minus 5 plus the derivative of the second. So that would be the derivative of this function. So that would be plus, let's see, 6x plus 2. So 6x plus 2, because 2 times 3, 6, and 2x becomes 2, times the first, which is x cubed, plus 4x. So ultimately, this whole expression, this is the derivative of this function right here. I might have to solve this for 0. So then I would be stuck with distributing 3x squared on these terms over here. But I don't have to. Well, I'll do that right now. What is 3x squared times 3x squared? That would give me 9x to the 4th. What is 3x squared times 2x? That would give me 6x cubed. What is 3x squared times minus 5? That's minus 15x squared. Then I'm going to come over here and get my 4. 4 on 3x squared is 12x squared. 4 on 2x, that's 8x. 4 distributed on minus 5, that's minus 20. Plus, remember, we have all of this stuff over here going on now. So that I'm just going to FOIL, right? First, outer, inner, last. So First times first. 6x times x cubed. That's 6x to the fourth. Outers, 6x times 24x. Or I'm sorry, I'm thinking ahead. 6x times 4x is 24x squared. Inners, 2 times x cubed is 2x cubed. And last times last, that's 2 times 4x is 8x. So we have a long run of terms here, don't we? All the way across here. So what we want to do is go and combine our like terms. So I have a 9x to the fourth and a 6x to the fourth. So let's see, 9 plus 6, that is 15x to the fourth. Sometimes what I teach students to do is identify them this way. Then I won't go back and double count them. Next, I want to do my cubic terms. So 6x cubed, and 2x cubed. So those are all the cubic terms, the x cubed terms. So 6 plus 2 is 8. X cubed. Then we go to our squared terms. Square, squared, and squared. So negative 15 plus 12, that's negative 3. Negative 3 plus 24, that's 21. So, plus 21x squared. And that takes care of this, and this term. So, then I have linear terms. So that would be, I'm going to do a squiggle here. That would be plus 8x. Then we have our constant terms. I'll do a different color. That's 20. So, I'm going to subtract that 20. So now I have the entire derivative in order from the x to the fourth all the way down to the constant term. The reason for doing that is sometimes we just need to set these guys equal to 0 and solve them in order to get our critical values. So that's it for that one. That one's a little bit more complicated. But let's look at one more. All right, last one, third example. Now we're looking at a trigonometric function. Here we have a cosine of x. But notice that, I'm going to put a little pink in here. This is a product, that's a multiplication. So this would be the first term, the first factor, f of x. This would be our g of x in that formula. So the derivative would be the derivative of the first. So f prime of x, derivative of the first. What is the derivative of x? Well, that's just 1. Sometimes I like to write the 1 in here just for emphasis. Times the second. Well, the second is just cosine of x. So I'd have cosine of x. 1 times the cosine of x. Plus the derivative of the second. What is the derivative of cosine? Do we remember? I think you do. It's negative sine of x times the first, which is x. So if you were taking a competency in my class, you'd be kind of done there. But it's always a good idea, if you know how to simplify these cats out. So cosine x. 1 times cosine x is cosine x. Plus minus, that's minus. Let's see. I have the sine of x times x. So I'm going to put the x out in front because I don't want to confuse it with sine of x squared. So that becomes cosine of x minus x times the sine of x. And that is number 3 for today. So I hope you liked it. Talk to you again the next time. So thanks for watching to the end. I do appreciate it. Make sure that you smash the like button. Don't forget, math is not a spectator sport. It's a participation sport. So you have to pay attention, do the work, and put in the practice. Most importantly, never give up. So if you've gotten value out of this, again, smash the like button and consider even subscribing. Catch you on the next one. Thank you very much. Appreciate it.